Welcome to the tutorial for loading masks and surfaces in Blender with microscopy nodes. Here I assume you've already seen a video where we load our data as volumetric data, and now we're going to go over how to load them as surfaces, but also how to load binary masks and label masks. For this video, I will do the first part in EM data, and the second part I will quickly touch on time series fluorescence data, but most of these things will translate similarly between fluorescence and electron microscopy. So I'll first delete all of these things in the scene and open our microscopy panel and put in an example file. All of the example files are in the description. So we have this one, and let's go not too large. This dataset is a FIB-SEM dataset with one channel of data, and then segmentations that were made manually in Amira by my collaborator for a lot of different structures within the cell. But for now, let's load only the data channel as a volume and as an isosurface. Let's turn the light bulb off for now because that's slightly easier to work with EM data. And then we press load and we get our object. So here this is similar to what we've already seen in the EM tutorial. But instead of only the axis, slice, cube, and volume, we now also get a surface object. So if we remove this, we can see our original volume, and we can of course slice through this. But now we also get a surface. So what is the surface? If we turn off the volume, we can kind of see this better. It is a single color mesh that that applies a specific threshold to the dataset. So if we have our data where everything is dark and light, we take a single value, and everything above that is inside the mesh, and everything under that is outside the mesh. And so this gives us this surface. And what's nice in Blender is that we can now also still change the threshold. So we can go to either a lower threshold, where we get only very low density structures, or we can go a bit up. And here we see all of these kind of tendrils, and we can also start to see our chromosomes, which I think we can even isolate a little bit better because they are quite distinct in this data set. And so let's look quickly at how the shader works for this, so how the colors get applied. In our shader for the surface, we get a color map, but that's actually not a real color map because this only has a single value, and so also we can only change, if we just change the last value here, we can change whatever color this has. And that's because essentially there's no other way to assign color than to just give everything a similar color. And that's a little bit sad because sometimes we have, for example, we now have all of these separate chromosomes, and we would really like to be able to color them all differently, because then we can show that they're all separate objects. So this is partially possible in Blender. You can also do some mesh editing, because this is actually, so what this actually is just fine meshes, which is like nodes with attachments that we draw a surface in between. And you can do with Blender's mesh editing, you can do quite some tricks to get this. So that would be, you would need to apply the Microscopy Nodes modifier, and then you can do mesh editing. But this is very complicated, and I won't really get into that. What I do want to get into is if you already have a label mask, either from your segmentation pipeline that you already have in like Amira or something like this, or if you have a segmentation from CellPose or some other form of AI tool, this we can then specifically load our pre-made segmentation mask. So we have here multiple channels of pre-made segmentations, and I'll load them as surface and as label mask to kind of show the difference. And for that, I'll already put it in the tab 10. So these are categorical color maps, which are also the same icon as the label mask. So let's see how this now looks. We have now a new object called label mask that I will quickly click away. And in our surface, we now have two channels, one for the data and one for the chromosomes. And so what's a little bit confusing here is that the chromosome mask that we've loaded doesn't actually contain all of our chromosomes. And that's because our threshold is too high, because what the isosurface assumes is that we actually do have a full data set with whatever data in there. And what we actually put in there now is this mask with specific label values. So sometimes the isosurface still needs some tweaking of the threshold when you're loading, but then this works well to get this single color version. And you can recolor that, but only on all of them. But this is for if you have a binary mask. This is very flexible because it's a lot faster to load this than to load it as a label mask. And so I would really, if you already have a binary mask and you want it in one color anyway, this works very well. But these are actually label masks where we have in our original TIFF stack or OMESR stack, we have a separate value, voxel value per object. And so if you have this kind of data, you can load it as a label mask, and this keeps the voxel value and attaches it to all of our objects. And then we can, for example, color or animate based on the object ID of certain objects. So if we go to our label mask, we now see that we also have our tab 10 color mask. This reads out the attribute object ID, and then it has a revolving color map. The other option is that it actually just ranges from 0 to 1, and that makes a bit more sense. If you have something like a linear color map, you can see that these ones have the lowest value in our original array, and these ones have the highest value. But for a lot of cases, it's nicer to actually have this revolving so that you can see more variation in local regions. And this is then sliced again. And so one thing you can run into with slicing is that you kind of want to slice separately your volume and your label mask. And so that's possible by just putting a different cube in here. And then this will be used for slicing it. And so this is essentially how the label masks work for single frame data. And so you can do all of this for each of these channels and combine them however you want. Then it's also nice to show how this works for time series data. So for this, I'll use a light sheet dataset, and I'll first delete what I have in my scene. I can do that either with delete hierarchy for a single set, or I can just do A and X, and then again A and X, and that also deletes everything. And then I put in my light sheet dataset, where we also won't go too big. And please note that this might take a while to load because it has a lot of time frames. So you can also just set your max time frames a bit lower to load first. I'll do it for now with the full 100 frames. And then we have a data channel again and a mask channel, where here you can keep it in blue and then it will just be shades of blue, but I like the tab 10, so I will go for the tab 10 and load this. So these are moving cells with a membrane stain and masks that were made in the toolkit Elastic, which are good but don't have complete tracking, but you can kind of also see that in the dataset itself. So now we have our data loaded, and I'll quickly go to the layout tab and to our view here, where we can now see our timeline here, and we can also press space and play it. So right now we have in white our surfaces from the CAX itself, from the membrane stain, from the data. So we can also make that fill, but then we see all of our noise here. And then we have the few ones that were successfully segmented, and we can see that those actually have are mostly tracked through time. So you can see that some of them kind of get each other's identity, but they do keep the same identity in Blender as they had in the actual original dataset. And so this way we can make movies of our moving cells as both with our segmentations and with our actual volumetric data, which is underlying here. Of course, we can go to our materials to set our alpha a bit lower so that we can see through things and see our data a little bit better. And what's important to note is that both the surfaces and the label masks also do get some light emissive properties when you load them with the light bulb on in microscopy nodes. This is because otherwise sometimes people lose them immediately on loading. So you can turn that off here in emission. But you can see that then they're really, really dark, which can be an issue for some people. One thing I also wanted to say, the generation of masks and surfaces can be quite heavy. And either you can always do it with a smaller version of your data, right? However, if you do want a very large data set, but you want slightly less resolved masks, you can also change your meshing density in the preferences. So you can get to preferences with edit preferences or with command comma. And then here there is the meshing density, and you can put this to fine, medium, or coarse. And even on the fine, you get a little bit more control, where in the surfaces you get, next to the threshold, you also get a voxel size option. However, the actual grid takes the actual grid size of the original dataset, which is a little bit heavier, but the most accurate representation of the underlying data. Thanks for watching. You can always reach me on Images if you have extra questions, or if you encounter any issues with microscopy nodes.